All right, so we've got two examples left to do to finish up our lesson on chain rule. So the first one, directions say to find the equation of the line tangent to f of x equal to 1/3 times x times the square root of x squared plus 5 at the point 2, 2. So the first thing we have to check with this is that the point of tangency? Does that point lie on our curve? Okay, so the way we check is to plug 2 in the place of x and see if that gives us a y value of 2. So when I plug 2 in the place of x, we get 2/3 times the square root of 4 plus 5, the square root of 9, so that's going to be 3. And 2/3 times 3 does in fact make the y value 2. So that's great. That is our point of tangency. So the only thing we need to determine here to find the equation of the tangent line is the slope of the tangent line. So we want to take the derivative of our function and then evaluate our derivative at 2. Okay, so if I want to find f prime, what I'm going to do is I'm going to take this coefficient of 1/3 and I'm going to pull it out front. Okay, so f of x is going to be equal to 1/3 times, and then I'm going to take the derivative of x times rad x squared plus 5. All right, so to do that, I'm going to use product rule. And now within product rule, I'm going to have to use chain rule to take the derivative of the second function. Okay, so using product rule, that's going to be the derivative of the first function, which is 1, times the second function, which is rad x squared plus 5, plus the first function, which is x, times the derivative of the second function. So rad x squared plus 5 is x squared plus 5 to the 1/2 power. So if I want to take the derivative of that, it's the derivative of the outer function. So my outer function is x to the 1/2 power, whose derivative is 1/2 x to the negative 1/2 power. We evaluate that at the inner function, which is x squared plus 5, and then we're going to multiply that by the derivative of the inner function, and the derivative of the inner function is 2x. Okay, now, because I'm just trying to find the slope at this point, like I don't have to simplify this derivative to find the slope, okay? I'm going to somewhat like rewrite things to make it like easier for me to plug 2 into the derivative, but I don't have to entirely simplify the derivative to plug 2 in. If you want to, that's great, but it's not required here. If you're just finding the derivative only, then yes, you have to go through and simplify that derivative just like we did for our examples in class. But I'm going to rewrite things slightly here. So we have 1/3 times rad x squared plus 5 plus, and then I want to clean up this expression here, okay? So the first thing I see that I can do is I can cancel this factor of 2 with that factor of 1/2. And then I'm going to rewrite that entire quantity back in the form of a radical because it's going to make it easier for me to evaluate. So we get x times x, which is going to make the numerator x squared. And then x squared plus 5 to the negative 1/2 power is going to put a rad x squared plus 5 into the denominator. Okay, and once I have the derivative written in this form, I can go ahead and evaluate that derivative at 2. Okay, so when I do so, we get 1/3 times the square root of 2 squared, which is 4, plus 5, that's the square root of 9, which is 3, plus 2 squared is 4 over the square root of, again, x squared plus 5. When I plug 2 in, that's going to be the square root of 9, which is 3. Okay, so if I want to simplify this here, you can like add up what's inside the brackets and then multiply by 1/3, or if you want to distribute 1/3 across both of those terms, that's fine. I'm actually going to distribute 1/3 across both terms. So 1/3 times 3 gives me 1, plus 1/3 times 4/3 gives me 4 over 9, and 1 plus 4 over 9 becomes 13 over 9. So that's the slope of the tangent line. And once we have the slope of the tangent line being 13 over 9, we know the point of tangency is the ordered pair 2, 2. So I can plug that information into my point slope formula. So that's y minus the y coordinate 2 equal to the slope 13 over 9 times x minus the x coordinate 2. And we've done like a lot of practice with tangent line problems. So you guys should be getting more familiar with working through problems of that type. Okay, let's move on to the last one, because this last one here, the algebra is super messy. That's why we're going to take the time to go through it. Okay, so directions here ask us to find the second derivative of the function. So we have f of t equal to the square root of t squared plus 1 all over t. Now for me, I don't think this is a good test question because you guys are going to see like how long and involved this problem is. It would take you guys too long to probably do a question of this type on your test. But let's go ahead and work it through nonetheless. So let's go ahead and take the derivative, the first derivative, f prime of t. So to take the derivative of this function, the first rule I have to use is quotient rule. Then within quotient rule, I'm going to have to use chain rule to take the derivative of the function in the numerator. Okay, so quotient rule, that's low, d high. So I can write the top function as t squared plus 1 raised to the 1/2 power. So when I take the derivative of that, that's going to be 1/2 times t squared plus 1 to the negative 1/2 power times the derivative of the inner function, which is 2t. Now I'm going to like simplify this over to the side so I don't have to like write f prime over again, like trying to rewrite that function. So again, just like in the previous example, we can cancel this factor of 2 with that factor of 1/2, and then I can rewrite this as t over the square root of t squared plus 1. Okay, so I'm going to do that. So this becomes t over the square root of t squared plus 1. So that's low d high. That's the low d high portion of quotient rule. Okay, minus high d low, the derivative of the bottom function is 1 all over low low, which makes my denominator t squared. Okay, so that makes f prime then. T times t is t squared over rad t squared plus 1 minus rad t squared plus 1 all over t squared. Okay, now we've simplified stuff like this in class already, okay? So we have like a complex rational expression here. I want to multiply the numerator and denominator by the common denominator of the smaller fraction, which is rad t squared plus 1. Okay, so when I multiply that by the first fraction, the rad t squared plus 1's cancel. So that just leaves me with t squared minus, when I multiply rad t squared plus 1 times rad t squared plus 1, that becomes t squared plus 1. Again, you have to make sure you subtract that entire quantity. And then our denominator is going to be t squared times rad t squared plus 1. And then when I simplify the numerator, we get t squared minus t squared. That makes the t squared terms go away. So that's going to make f prime of t equal negative 1 over t squared times rad t squared plus 1. Holy crap. So we did all that work just to find the first derivative. And we still have to find the derivative of that to get our second derivative. So let's go ahead and do that. So f double prime of t. Again, I'm going to use quotient rule. So to find f double prime, you can do that one of two ways. If you want to rewrite this function f prime as like -1 times t squared rad t squared plus 1 raised to the -1 power, like you can do it that way, and that's perfectly fine. Or if you want to use quotient rule, that's okay as well. I'm gonna go ahead and use quotient rule. It doesn't matter which approach you take. Okay, so using quotient rule, it's going to be low. So that's t squared rad t squared plus 1. D high, the derivative of the top function, is 0 minus high. So that's -1. D low. So for me to take the derivative of the bottom function, I'm going to have to use product rule and chain rule both. Okay, so when I take the derivative of the bottom, that is going to be the derivative of the first function, which is 2t, times the second function, rad t squared plus 1, plus the first function, t squared, times the derivative of the second function. Now, we already did the derivative of the second function, rad t squared plus 1 up here, okay? And we found that to be t over rad t squared plus 1. Okay, so we just want to go through and simplify this. So this becomes 2t rad t squared plus 1. And then t squared times t is going to make t cubed over rad t squared plus 1. Okay, so that's low d high minus high d low all over low low. So that's going to be my denominator, t squared rad t squared plus 1 quantity squared. Okay, so this right here is 0, so I don't have to worry about that. All right, we have the minus -1. That's going to change the sign here to plus. Okay, so f double prime of t is going to be positive 2t rad t squared plus 1 plus t cubed over rad t squared plus 1. And then on bottom, like when I apply that exponent of 2 to both of the factors, t squared squared is t to the 4th power, and then rad t squared plus 1 squared is t squared plus 1. Okay, and then I want to simplify this just like I did up above. So I'm going to multiply the top and bottom by rad t squared plus 1, the denominator of the smaller fraction. Okay, so when I do that, that's going to make f double prime equal to 2t times rad t squared plus 1 times rad t squared plus 1 is going to become t squared plus 1 plus, when I multiply rad t squared plus 1 times the second fraction, that just leaves us with t cubed. And then my denominator is going to be t to the 4th power, and then t squared plus 1 times t squared plus 1 to the 1/2 power is going to make t squared plus 1 raised to the 3/2 power. Okay, we're getting there. We're almost done. Okay, so when I distribute in the numerator, 2t times t squared plus 1 is going to make 2t cubed plus 2t plus t cubed over t to the 4th power times t squared plus 1 raised to the 3/2 power. And then I can combine like terms in the numerator. So 2t cubed plus t cubed is 3t cubed plus 2t all over t to the 4th power times t squared plus 1 raised to the 3/2 power. We're still not done simplifying yet because I can factor a t out of the numerator. So if I factor a t out of the numerator, that leaves me with 3t squared plus 2 over t to the 4th power times t squared plus 1 raised to the 3/2 power. And then I can cancel this factor of t on top with one of the factors of t on bottom. Okay, so that is going to make f double prime equal to 3t squared plus 2 over t cubed times t squared plus 1 raised to the 3/2 power. And that right there is the second derivative simplified completely. So let's zoom out to see how long this problem was. So that might be the longest problem you guys have ever worked out in your life right there. But it's a really good exercise for you guys when it comes to simplifying derivatives. Okay, so that's it for this section. And like I said, like this section of chain rule is so important going forward in calculus. Like if you understand this section really well, it bodes a lot of success for you down the line because you'll understand how to take the derivatives of any type of function and then also be able to utilize like applications of derivatives as well. So implicit differentiation, the next lesson that we're going to go over, like builds on chain rule a lot, as well as related rates, which we're going to go over in the section after this. Okay, so you guys see that like the math in this section gets a lot more challenging, a lot more difficult, and that's going to be the case in this section and in the next two sections that follow as well. But again, like you guys can do this, like we worked through some good solid examples here, and if you guys understand this stuff well, like I said, you guys should do fine moving forward. All right, so that's it. You guys have enough to be able to do your homework assignment, and then we'll see you in class next week. So I hope you guys have a great weekend. Take care.